Yes, good evening, Chandrasekar sir. Sir, I think mic problem.
Hello, can you hear me?
Yes, sir.
Yes, sir.
We can hear.
Okay.
Good evening, sir.
Good evening. Sorry, I had to change the laptop because my office laptop, the Google somehow had some issues and it kept throwing me out of the meeting. So I need to move to my personal laptop.
It's okay, sir. It's okay. Disha, can you start the session? Disha?
I cannot hear anyone.
Sir, we can hear you, sir. We will start the session soon, sir.
Yeah, you're asking somebody to start.
Yes, sir. She
Yeah.
will start.
Am I audible?
Yes, Disha, you're audible.
Okay, then get it. I will start. Can I get a heads up? Can we start?
Yes, Disha, you can start.
Thank you, sir. So, to curious minds and passionate selves, that is to the engineers to be and the intellectuals on the virtual dais, I, Disha Ibrahim, take joy in being your host today. On behalf of Cloudzilla, it gives me immense pleasure in extending to you a very warm welcome to the Tech Talk on recent trends and opportunities in cloud computing. So that you know who we are and what we chose to do, I would now invite our club lead, Anish, to take over. Over to you, Anish.
Thank you, Disha. Good evening to one and all present here. Myself Anish, lead of Cloudzilla NMIT. I am here to brief about the club. Cloudzilla is a student-driven club. As we all know, Zilla means district. So we are a community of like-minded people interested in cloud-related technologies. The main aim of this club is to help the fellow students in realizing computing opportunities within the cloud and to provide a platform for the students to learn, explore, and build their interest within the cloud. The following programs have been planned by our club: career readiness program, workshop, hands-on sessions, orientation programs, tech talks, seminars, hackathons, mini projects, certified courses, programs from companies like Google, Azure, etc. And many more are yet to come. This is just the beginning, so let's all join hands and make this platform a successful one. Thank you.
Thank you, Anish. Now I would like to invite the Cloudzilla faculty lead and the convener of the day, Mr. Mohan Kumar TG, to address the gathering. Thank you. Over to you, sir.
Yes, good evening to one and all. Cloudzilla, I am proud to say this club, it is the main initiative from second year IC students. Under this technical club, we are planning to conduct so many programs such as what Anish said, career readiness program. Under career readiness program, we are doing with certification courses. So from the AWS, Azure and the Google Cloud, I talked with the Google Cloud program manager. He agreed to give 50 licenses in AC certification course and in 25 licenses in data analyst course, so that students, they can enhance their cloud skill, and also it is an added advantage for your resume. Apart from this certification courses, we are planning to conduct a technical talk like this, also seminars, hackathons, so many programs, it is on the line. Then I wanted to say thanks to Chandrasekar R sir for accepting our invitation to deliver technical talk on recent trends and opportunities in cloud computing. Dear students, please make use of this session and clarify your doubts in cloud computing. Also, I wanted to say many thanks to our beloved HOD Dr. Mohan SG sir for his continuous support for arranging this technical talk. Then I wanted to say thanks to our previous HOD Dr. Sanjay HA sir because he is the main reason to start this technical club, that is Cloudzilla. Thank you. Over to you, Disha.
Thank you, sir. I would now like to request Dr. Mohan Kumar SG, the head of the department ISE, to say a few words. Over to you, sir.
Very good evening to all of you. Thanks, Disha, for hosting this event. Thanks for the opportunity to introduce our beloved guest, Mr. Chandrasekar R, who is the General Manager, Cloud Services for the Cloud, IoT, CX, AR, and VR. He's from Bosch Global Software Technologies. Here is the profile. With over 2 decades of experience in automotive engineering and the IT domain, contributing in software and product development, program management and delivery management, Mr. Chandrasekar heads the cloud and IoT customer experience and immersive practice at Bosch Global Software Technologies. As head of the cloud, IoT, and CX practice, Chandrasekar is responsible for delivering end-to-end IoT solutions for multiple domains, including manufacturing, automotive, retail, e-commerce, CRM, and smart city. In 2014, Mr. Chandrasekar, the chief platform manager, was responsible for the launch of the first connected vehicle powered by IoT by Bosch, creating a $200 million business. He critically managed the end-to-end responsibilities of product design, development, product validation, and certification for global markets and industrialization setup. He's a computer science engineer from Madras University. He also has a Master's of Science from BITS Pilani. In addition, he has completed the Executive General Management Program from IIM Bangalore. Mr. Chandrasekar is also passionate about innovation and is responsible for the BGSW IoT Garage, an incubation center for experimentation and digital transformation with the latest IoT technology across sensors, software, and services. He's also involved in partnering with leading industry players across technologies and domains and collaborate with academic institutions, startups, and leading business forums. We are really honored to have such a uh, expertise, such an experienced person for our technical talk. I'm sure Cloudzilla members will be really benefited from his talk today. I take this opportunity to welcome Mr. Chandrasekar, and I also extend my hearty gratitude for accepting our invitation and to be a host here. Thank you very much, sir. Over to you.
Yeah, thank you, Mr. Mohan or Dr. Mohan. I'm not a doctorate. Thanks for that kind introduction. I just want to have a few questions before I proceed. The audience here, the participants in this call, uh, what kind of which year they are in, which is the main discipline?
Sir, first semester.
First.
First year.
Sir,
Sir,
first
semester.
semester.
Okay, good. Yeah, thanks. And it's ISE, right? Information.
Yes, sir.
Yes, sir.
Yes, sir.
Yes,
Yes,
sir.
sir. Okay, thank you. Yeah, so then understand how I'm sure that irrespective of the age or year, you must be already living in this digital world. I have to share my desktop. Chinmay, Adisha, can I do it just like that, or I need to ask for permission? Okay, I can do that, right? Okay. Let me present the entire. Let me know when you can see my screen. I see a lot of things, but hopefully you are seeing a presentation now when I show this. Can you confirm that you are seeing only the slide so that no other?
Yes, sir.
Yes, sir. Yes,
Okay,
sir.
yeah. Thank you. Yeah, so good evening to all. I know it's the end of the day, but I have been given close to an hour. I would try to keep it, I would say, shorter, but also kind of more. That's something that you would like to hear. And please, if there are any questions, maybe we can have it at the end. Please note down your questions, and I'll take you through this presentation. I have tried to cover as much as possible under the topic cloud computing trends and opportunities. If there are any specific questions beyond the slides, we can also have it at the end. Yeah. So yeah, we have one important point I want to show or kind of mention here. The slide is slightly in terms of format. We had used the earlier slide, but from last 3 days, we have been called a new way. We are no longer called as Robert Bosch Engineering and Business Solutions Limited. Rather, we have been called as Bosch Global Software Technologies. So this is a new name, and this is, I would say, the first part of Bosch world, the first company to have purely a software technology as a name. So this kind of makes a very big difference for us because we have been identified as a global software technology arm within the Bosch world. I don't know how many of you know Bosch is a pretty big organization. We are close to 4.5 lakh associates, close to 125 years or 30 years now. And we are in terms of revenue, we are close to $80 billion company. And in that company, as an Indian arm, Indian subsidiary, to be recognized as Bosch level global software, it's a very big moment for us. So we had a lot of party in terms of having celebrations and kickoff this week, and that's why you see this logo. But my rest of the slides are not fully updated, so I would want to ensure that it's still I'm part of Bosch Global Software Technology Limited. Okay, so now we come to the topic. I know most of you, what I call as millennials, all of you, I'm sure that if not all, most of the names that I mentioned here, I'm showing it here, you are all part of it. And probably you have it in your phone, half of these apps So I have not spent time going through that, but you can see that a lot of them are highly computing intensive data storage. I'm sure that you all could understand how much pictures Facebook will have, how many videos YouTube will have. I think like millions and millions of hours have been gathered over the year. This is, I'm talking about 1 minute in a day, how much data is collected. Yeah. And yeah, I think most of them are covered. There are more beyond that. These are purely the B2C or consumer social network platforms, but we also have a lot of business to business, B2B, or other applications are running which probably are not fully using it. Do we have Amazon here? Yeah, Amazon here, but we don't have Flipkart, for example. Yeah, so quite a few are missing out, but you can understand how amount of data that runs through this. And I can tell you that almost 99% of all these applications, all these platforms are running on cloud. Yeah, you cannot imagine such a huge, I would say, amount of data transmission, streaming, and storage and processing and building AI on top of it. This cannot happen without cloud right in the middle of it. And we also are talking about what we saw was primarily social networking, but we also talk about digital transformation, right? I mean, this is the keyword that probably are, it's a kind of buzzword that you can hear throughout the industry when it comes to IT or any, even any industry. Everybody's talking about going through digital transformation. Yeah, we'll come to that later. But at the center of the entire digital transformation as a topic lies cloud. So as you can see here, we are primarily talking about digital transformation when it comes uh, driven by IoT, yeah, in terms of operational efficiencies, in terms of coming up with new business models, new revenue models, new products and services that can be offered. This all starts from the bottom and with connected things, for example. But again, central, you can see the data ingestion, the data visualization, storing it, processing it, and managing these devices in the backend. All that happens in cloud. It's a centralized cloud platform. Of course, a cloud does not exist without communication, which is basically the internet that we are talking about here, whether it could be Wi-Fi, Bluetooth, or your cellular connectivity or LoRaWAN, whatever. Yeah. So that's a connectivity part of it. Of course, on top of it, we have a lot of new techs, ML, AI, blockchain, AR, VR. And then with all this, we build the real applications, whether it is Industry 4.0, consumer IoT, logistics, connected healthcare, connected products, anything that you can talk about. All of them are depending on this layer. This is a common layer when you are talking about any digital transformation. And as you can see, right in the middle is cloud. So there's no digital transformation that can be visualized without cloud, whether it's private, public, or hybrid. So how did we end up here? Cloud computing is what you see on the right at the end. But where did all started? I know you probably, many of you are not born, even I was not born in 1960s when we had mainframes, this huge, massive machines which used to do bulk processing tasks, and it's primarily input output. The capability in terms of processing is limited, and the amount of power and effort it consumed was very high. That's where it's all started. And sometime in 60s we started getting into personal computers, which again becomes central. So you see a theme of centralized and decentralized. Yeah, everything is central. So mainframes, you have to go to the mainframes and work with them. It doesn't come to your place. Then personal computers where you can keep it with you. And that's when most of you know that this entire internet, what we call as WWW, World Wide Web, started as part of the military arm of US, where they wanted a network that could help them to communicate within this organization called ARPANET. And that's one of the I would say genesis of internet started there. And the 70s there was a major, I would say, milestone achieved where the virtualization was possible, which means that in the same hardware we are able to load multiple different operating system at the same time, yeah, in a specific instance. And that was another I would say milestone that all contributed to the cloud. Then of course again it becomes centralized. So we have internet applications. So you have cloud, you have this three-tier architecture, and that means you have database, you have front-end applications, you have the middle tier, which is what we call it as client-server architecture, three-dimensional architecture. And we also started getting into services-oriented architecture. This started from 2000 onwards. And now we are coming back to centralized. Yeah, so we are talking about cloud. So what does it mean? Mean all your necessary resources, whether it's computing, data storage, database storage, or all of the IT operations, monitoring, everything happens in a central location, which is not necessarily owned by you, and you are able to consume, you are able to develop and deploy your applications on top of this cloud, which helps you to reduce your upfront investment costs, right? You don't have to own hardware to start any of your business. You simply have to rent it from any of these platforms. So that's basically centralized cloud enabled application. And now again, we are also talking about how the cloud can be distributed. And now we are talking about a blockchain, for example, which is completely distributed. You're talking about cryptocurrencies and all that. Since this goes, it has gone through a lot of this journey. It will not stop. I think we will continue to find new ways of way of solving problems, building applications, connecting people, helping people to live better, and helping business to come up with products better and offer services better to the end customers. So if you look at in terms of what are the different things that changed over the timeline, if you say mainframe, PC, client server, web services, and now we are in cloud computing. So when it comes to software deployment model, it was primarily centralized. You have to go and deploy it in one server. And now you are talking about completely distributed. You are talking about microservices, right? You're talking about serverless. So you don't have to worry about deployment. You don't have to go to different regions to deploy. You can put it in one server, and then this is automatically made available to all the users across the world. Because if you have a phone, for example, I'm sure that each country has different connectivity, different phone, but there's nobody it's not done at a country level, right? You have this photo over there, it is done centrally, and then all that software is deployed into your phone without even you realizing it. There's an always update happening in all your apps in your mobile phone. So the consumption model it was again centralized, and now it has become self-service. So you can choose what kind of services that you can offer in cloud. You don't have to. There's not a. You kind of get a menu that you can choose yourself. I want hardware. I want additional database. I want additional processing capability. It's completely self-service. The SLA models. When I say SLA, it's service level availability, and then it was earlier completely extreme. One extreme was uptime, and it was very expensive, and then they designed for failure, and now it's completely on, means all the time on. You literally have you can't say 100% because the servers go through downtimes, but you don't see it. You see completely none of the servers look like down. If any of them go down, I think it becomes a big news. You know that Facebook was down recently, WhatsApp was not working. So this doesn't happen by design. These are normally failures, but ideally they are not supposed to happen. And again, the scaling model, but horizontal, when I say horizontal means more additional pieces, but it becomes vertical. So you just have to have only the necessary resources for you. You are not talking about adding computers per se. So when we come to definition, a few definition, because in the colleges you are normally expected to write down the definition. So what is cloud computing? It is nothing but on-demand delivery. Depending on your need basis, the delivery happens of what? Computing power, database, storage, applications, and other IT resources, let's say network, for example, as well, through a cloud services platform. So it could be your cloud tech OEM clouds, for example, Microsoft, AWS, GCP, IBM, HP. There are quite a few players out there. Via the internet, obviously, when you're talking about public cloud, it's always connected to your internet. Private cloud can also be connected to your local network, but also can be connected via internet with pay-as-you-go pricing. I think this is very, very important for you to understand. It is not that you have computers and then locked for you and you pay for the whole thing. You pay as you use, yeah, pay per use, like how you are using the Uber, for example, yeah, Uber or Ola. When you're booking, you don't buy the car, you don't own the car, you don't pay for the fuel, you just use for taking a service to commute from X to Y location, and you only pay for that. And then after that, you just go out. You don't own the car. So this is the same principle, same business model that's applied everywhere, and that's same. It's also applicable for cloud computing as well. So Salesforce, how many of you know? I'm not sure whether many of you are aware of it. You might be knowing them as a CRM and app development platform now, but they have a very they were the pioneers. when the CRM solutions were CRM, when I say CRM, customer relationship management product or solution, which basically helps any organizations to communicate with you. For example, if you have, let's say you have a Swiggy or Zomato, there is a call center and there's a request that you raise, and then somebody delivers that. If there's a problem, then it goes back. If you're buying a car and there's a CRM system which helps you to tell you when the services has to happen, when you have a shutdown, when you have a problem in your car, then somebody comes and fix that, service technician, and then he goes back and he updates the whole system where the interface happens with end customers for any organization. This is managed by something called as customer relationship. So when you go there, they have the history of what you have done, what you've bought there, what kind of services you are offered. So that history helps them to provide you better services. Yeah, this is basically called a CRM. And at that point of time, the big giants were quite a few were there, but of course SAP was the leading one, and the CRM systems that they offered at that point of time, there was nobody else was offering, was primarily a huge software that would be installed in your backend. There's no, I would say, cloud was not there. Rather, it was not still called as cloud per se, but they normally have your local data centers. Yeah, and this software used to be very expensive. When you know SAP, it's normally a huge set of the complete ecosystem they install. It interacts with your ERP systems, you interact with your HR systems, it interacts with all other functions, and the CRM system was one of the systems that was built. So you need to have the whole hardware, software, and the complete necessary resources set up for running this application. So this was the norm. Yeah, it's not just SAP, everybody was using the same. But then came Salesforce, and they came and completely changed the story. Yeah, I'll just give you a video. Hopefully you can watch it. You can hear it as well.
You have big ideas to streamline your business and drive sales through the roof.
Okay, I want to switch. Okay, done. Yeah, can you hear that video? I just want to check before I continue.
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Yeah.
But to get there, your ideas need business apps. And business apps have always been too expensive, especially in times like these. Behind each one is a world of complexity. They need a data center with office space, power, cooling, bandwidth, networks, servers, and storage, a complicated software stack, and a team of experts to install, configure, and run them. You need development, testing, staging, production, and failover environments. And when there's a problem, good luck. You call technical support, and they don't know, so they blame someone else. Oh, and when new versions come out, you would upgrade, but that might bring the whole system down. Now, this is for one app. When you multiply these headaches across dozens or hundreds of apps, it's easy to see why the biggest companies with the best IT departments aren't getting the apps they need. Small businesses don't have a chance. Cloud computing is a better way to run your business. Instead of running your apps yourself, they run on a shared data center. You just plug in, like a utility. This makes it fast to get started and it costs less. It's like Gmail compared to Microsoft Exchange. With Gmail, do you need servers and storage? No. Do you need a technical team to keep it up and running? No. Do you have to do upgrades? No. When you use any app that runs in the cloud, you just log in, customize it, and start using it. That's the power of cloud computing. This model is so much better, it's changing the way we think about software. Not just for consumer apps, it's also being used for business apps. We call this enterprise cloud computing. Businesses are running all kinds of apps in the cloud these days, including custom-built apps. Why? Because you can be up and running in a few days, which is unheard of with traditional business software. They cost less because you don't need to pay for all the people, products, and facilities to run them. And it turns out they're more scalable, more secure, and are more reliable than the vast majority of apps out there. Here's why. They're based on an architecture called multi-tenancy. With a multi-tenant app, there isn't a copy of the app for each business that's using it. It's one app that everyone shares. But it's flexible enough for everyone to customize for their specific needs. It's like a giant office building where everyone shares the infrastructure and services, like security, yet each business can customize their own office space. This means apps are elastic. They can scale up to tens of thousands of users or down to only a few. Upgrades are taken care of for you, so your apps get security and performance enhancements and new features automatically. Now, the way you pay for cloud apps is also different. Forget about buying servers and software. When your apps run in the cloud, you don't buy anything at all. It's all rolled up into a predictable monthly subscription, so you only pay for what you use. Finally, cloud apps don't eat up your valuable IT resources, so your CFO will love it. And you can focus on projects that really impact the business, like deploying more apps. Cloud computing is a simple idea, but it can have a huge impact on your bottom line. For more information, go to salesforce.com/cloud computing.
So as you can hear, this video is in 2009. Yeah, it's not a new video. So at that point of time, whatever they were saying was completely groundbreaking. It was not common to have like that. So a complex CRM solution, which rollouts happening even nowadays in SAP, even in Bosch, in certain areas we do that. It runs for almost 6 months or 3 to 6 months, I would say. But Salesforce was able to deploy it in just 5 days with cloud because everything is configurable. So they just come and sit with you and then understand requirement and they simply will configure the entire cloud. I mean, because the solution is in cloud, they have to only configure it and they have to make it available for available to you, an existing platform interface to you in a with the requirements that you have. So same set of instances, same platform that can be used by multiple customers and very customizable so that the customer gets what they want, not everything that Salesforce offer. So you are able to divide the entire software modules in a way that you offer, for example, I need only 3 out of 10 and somebody wants 4 out of 10, only that is offered and you only pay for that. Whereas earlier with SAP, if you see some of the names, Microsoft SAP, so they were clearly targeting them that they did not have at that point of time. They were offering complete software. You have to buy and download and pay for licenses and you have to pay for hardware as a huge cost. And that point of time, it was unheard of somebody like something like that can happen, and Salesforce made it happen. And they are really, they have got a huge share in the entire market in the CRM space, and they are continuously growing. But they were the first pioneer in the cloud computing story, a first multi-billion dollar company coming out of cloud computing as a basis for their business. So this is something that if you read more about the Salesforce, you will know. But of course, now things have changed. Microsoft offers the same CRM with the Dynamics 365. You have SAP also offering C4C. So they all are now migrating. They are now changing to cloud. But Salesforce had done it long back, more than a decade back, and they have really taken the market. And all the small companies, medium-sized companies who do not have a lot of investments in either Microsoft or SAP, they were able to quickly migrate to Salesforce with very less time or big investments. So when we talk about cloud computing, you probably already would have heard this. We have a lot of things we call as information, infrastructure as a service, platform as a service, and software as a service. So I've given you a simple what we call as PIDGA layer, or even in your operating system, the layers that you would have read. So you have this, what happens in on-premise. When I say hello, this is completely managed by you as a business. Yeah. So whether it's networking, storage, servers, virtualization, operating system, middleware, runtime, data, and application, the whole thing you own, everything including hardware. So it's a huge investments that you make, and this is still in many companies done, but everybody is migrating it. Then you have infrastructure as a service where you completely take the infrastructure alone and then you build on top of it with your own operating systems and they use. This is the first step of migration. Primarily when people go to AWS Azure, they would start with infrastructure as a service they will take because then they will simply have to not have to invest on the servers. That's the first step. Then we get into the platform, which means that you also have OS and middleware runtime. So Azure is one. They primarily enable you with Azure, not per se, but most of the offerings start with PaaS. So where you only have to manage the data and applications. And then comes SaaS. Okay, this is your typical. We already discussed about Salesforce. So as a company, you're not because if I'm using Salesforce, I don't have to maintain even the application because that is also done by Salesforce, and they take care of all the application support, implementation changes, so that I just only use the software and then make sure that my customer expectations are met, the requirements are addressed, I have a good customer engagement happening, and I'm able to build my business on top of it. So one clear example that was already shown was Gmail, right? This is a typical SaaS model. You don't own anything, you just use it, consume the product. But of course, in that case, we are end customers, we don't pay for it. That's a different model that Microsoft, Google provides you. And I already talked about Microsoft Dynamics, the CRM, which is again on a SaaS based model. Yeah. Then we have different ways. We also see how the deployment happen. Yeah, we have this private cloud, we have public cloud, and hybrid cloud. It's very simple. Private cloud is nothing but where you keep it inside within your campus. It is fully restricted. Of course, this means highly secure. And many of the companies, I would say, typically what we call the US companies in the United, the America, North America, and South America, they are not very particular about the security. They are, of course, but they are very open to migrating. That's why their adoption of public cloud is very high in that region. Whereas a European region, for example, is very particular about the data. They worry about the security of the data and data privacy, and a lot of other things. So they tend to have a lot of private clouds. And I can tell you that Bosch is going for a hybrid model, which means that we will have certain data, certain amount of information, applications that would be exposed as part of customer engagement, because Bosch works with so many customers, whether it's BMW, Daimler, or any other big automotive or non-automotive. We will have a lot of interactions. For that, we use public cloud. But any intel information, employee information, anything, for example, IP information, yeah, intellectual property, patents, or our core research papers, R&D documents, all those information would not be going to public or hybrid cloud. So it will be part of our internal private cloud, and that's why we choose that. And Bosch is also a European country. Bosch is also part of European region, and there normally you will have most of the companies following hybrid, private or hybrid. Very few will go for public cloud, especially the big organization tend to be reluctant to move to public cloud, and that's a typical of the region. And but the things are happening with more and more security audits, security certification, and lot of legal, I would say, compliances. Now there's a lot more confidence in going to public cloud, and not in hybrid cloud alone. So this is happening, but I would say the trend is still relatively lower compared to either India, China, or in US. So what are they? I mean, I'm just refreshing because you are talking about Cloudzilla, and I'm sure that most of you have the basics, but I just still touch upon so that you get a overview of that before we get into a little more complicated topics. So private cloud, the complete resources are exclusively used by one organization. So if I have Bosch, if you have a private cloud, it can be only used by us. Yeah, they are physically, most of the time, physically located in our company's internal data centers. For example, just to add to it, Germany also insists that whether it is Azure or AWS cloud, or all the data related collected within Germany has to reside in Germany. It can be public cloud, but the data should not go out of Germany data centers. Yeah, they have got legal requirements like that, and because of that, that's what I mentioned. So they were adapting to public, but very restricted, a very constrained way, so that they want to be assured that at no point of time the data generated out of Germany should, per data alone, I mean data level, should not be made available outside that region. But your applications can make them available, but the data center should be within the country. Yeah, this is very it's an important need for any of them. So if you see all of them adapted, so Azure, AWS, so any data generated out of all the IoT or any of the applications within the Germany region, Germany would be only stored there, and there won't be any replica would happen. Yeah, so this is a very specific need of German region or European region, including Germany. So again, coming back to the services infrastructure, everything is maintained on private. Yeah. Then on the right side, completely owned and operated by third party, Microsoft, Azure, AWS, Google. Everybody has clouds. Even Bosch used to have a cloud, but now we are slowly moving out of that business. So that's owned by third party cloud service provider. You don't have to buy anything. Everything's owned by them. You only take either infrastructure or platform or software you are going to use. Hybrid, I explained, so it's a combination of both. The data and applications would be partly here internally, partly also in public. So I already gave an example of how Bosch operates. Yeah. So beyond that, we have community cloud that can be created within among the community. We could also have multi-cloud. So this is also possible that to avoid a vendor lock-in, this is also a trend that more and more companies are looking at engaging with both, let's say Microsoft and Azure, or Google and Microsoft, or AWS and Google, so that they don't want to lock into one, and they try to get the benefits of a particular cloud service provider which is specifically in an area. Then they want to consume that, and if it's commercially is much more cheaper other area in a specific area, they want to use that kind of cloud. So this is also the kind of a trends that I one can see in the market. So market share, this is just for you to understand where the industry is going. As you can see, AWS was the front runner. They started first and they are continued to hold this big share. So 32%, they have not changed over the years. They are continuous, because I mean, you should not see this that, okay, they are still at 32, but the market size is increasing tremendously. Yeah, which was earlier 10 billion, now it's 150 billion market, just pure infrastructure services alone in cloud computing, and they are still retaining the percentage. The growth rate of Microsoft is much higher, as you can see after Satya Nadella has taken over. He kind of pioneered Azure cloud in Microsoft, and he's really changed Microsoft into a Azure. He wants Azure to be the computer of the world. Yeah, and you can see that their growth is almost in 3 years has doubled literally. We have also Google making a lot of effort to come into the enterprise, and there are a lot of other small, including Alibaba, IBM, and others. So when it comes to developing for cloud, so you have the infrastructure part of it. That is one part. The other part is building applications. So there are a lot of aspects are there. I'm not going to go in detail. So you have easy deployment possible. So you can have continuous deployment, including DevOps is possible. And you're also having advanced cloud services. For example, you don't have to build algorithms for computer vision. You don't have to build algorithms for machine learning. These are available for you by default. For IoT, for example, each of these platforms provide IoT modules for you to quickly adapt, quickly able to connect, and then make your deployment faster. This is possible, and of course, this is literally technically not possible, but literally you can have unlimited resources if you are in cloud. You want to have million users, possible billion users, it's possible. Technically, it's possible. Yeah. And we are talking about serverless computing, and we also talk about pay per use. So you only use for that, and you have global data centers. I think even in India, all of them have set up their global, data centers already. Both of them are competing. AWS, of course, is leading, but Azure also is almost on a monthly basis. They are opening new data centers in specific countries, regions, as well as uh, continents. I talked about DevOps. So this is another important thing that has happened as part of cloud as well, where your entire development and operation is integrated as DevOps, and you can see different types of products or solutions or players who are in this in different phases of this DevOps. So basically, you develop and immediately the operations you're able to deploy it. Yeah, this is not so easy. When I was a developer, it was never easy. You have to deploy, you have to develop in development server, then we test it, and then we have a specific in a production server. We have to try it out, and they are not physically in India. We have to deploy it in Germany, and then further we need to get approvals, and we need to have slots where you can go and do that. It was very complex, and normally a release can happen 3 days. Yeah, now with the DevOps and in cloud, these things happen. You as soon as your testing is completed, you are going to clear the QG gates. The deployment is pretty straightforward. It is automated, completely script based, and it automatically is done without manually triggering this process. So this is something is one of the major things that have happened. DevOps is a very important topics as part of both development as well as operations. I know all of you, most of you would have Netflix in your mobile app, and I'm sure that okay, so I just want to run for information. Netflix, you can see the complexity is very high because you're not talking about data, you're talking about videos, which are very huge in terms of size. They need huge storage, and they are very, very complex to handle, and it's not easy. Yeah, running an Amazon or a, yeah, much more comparably speaking, Amazon is easier when you compare to Netflix. And each one of you have a Netflix, right? Because you don't have the same, because it's completely customized, personalized based on your history, based on your profile. So literally they talk about having million versions of Netflix, and this is possible because of cloud, and they work with AWS.
Success with the AWS infrastructure can be attributed to the scalability, elasticity, global availability of the service, as well as the key focus on velocity from AWS development team. My name is Eva Say. I manage the big data platform team at Netflix. Netflix is a global destination for people to enjoy great movies and TV shows. Our goals is that you will always find something that you enjoy to watch on Netflix. We are located in Northern California, the city of Los Gatos. We have over 2,000 employees, all of which 2/3 have technical roles. And Netflix is largely technology-driven and technology-focused company. So in 2009, we knew we would be attempting to build a global internet television service one day. And we were in a data center. And at that time, we were thinking about moving to AWS Cloud already. So it just makes sense for the big data platform team to be the first one to lean forward and build it from the cloud right from the beginning. We have tens of thousands of instances running across 3 different regions in AWS. We have hundreds of microservices. We serve hundreds of thousands of requests per second, and we serve over 1 billion hours of content per month. And all of these are running out of AWS infrastructure. As we move to the cloud, our engineering organization has also moved to more DevOps oriented. Combine that with the Netflix culture of freedom and responsibility, our developers or engineers can actually have the freedom and use the judgment to spin up instances to do tests and experiments at any time. It only takes seconds or maybe minutes to spin up new instances or new Amazon services for the tests, versus in the past, they would have to talk to IT and it would take maybe days or weeks for those hardwares to be procured. A service like Netflix, elasticity and scalability is extremely important. So having a service like AWS Cloud that could expand and shrink its footprint based on traffic is really important for us. And also we're continuously to grow our customer base. We'll get more and more customers. We just need a service that has the capacity that we could grow into to support many more users than today. Our users just now take it for granted. They expect that when they turn on the Netflix service, it would just work. And part of it is attributed for the fact that we're now on AWS Cloud.
So I think all of you have must have, most of you should have Netflix, if not Amazon Prime and all of it. And you can see the way they are able to deploy in seconds and minutes, when it was earlier used to take months or weeks sometimes, and it's not so easy. And now they are able to do that. And I hope that in this participants, most of you are at this point of time consumer of Netflix. I'm sure that in 5 to 6 years, you will start working on building such systems, because you are the users and you know the complexities as an engineer. I'm sure that you all are interested to build something like this, not necessarily Netflix, but such systems, which again will be used and consumed by millions of users or customers. So another video just to connect on the Bosch part of it. So I'll come to the Bosch, what we do. Quick intro before we get into the trends.
I'm only allowed to have 1 hour of gaming a day. Well, I'm so old school.
Yeah, totally.
Old school? Really?
Challenge accepted. Accepted.
Let's start the show. High-tech pro. Smart machine. What's up, teens? I'm baking smart. Fancy art.
Complete. All is neat. I'm riding heat. Sustainably. I navigate. Never late. Then checking in. Safety wins. I watch my kitchen. Hungry kids. Such bad air. I take care. Get in the car. High tech star. High tech star. High tech star. Front radar. Safer car. I own that place like a Bosch. Hot space. Yes, you won. High tech mom. 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 Live like a Bosch with many intelligent, connected, and sustainable solutions. From Bosch.
It's a moon rock from the moon. Moon rocks are old school.
Yeah, totally.
I did two. I think we
All right.
one seat.
Okay, I hope that was fun. But basically, it demonstrates the different kind of products and solutions built in Bosch across the world, and whether it is car, whether it's your home automation systems, your consumer electronics, including your oven, everything is we are trying to connect, and of course, all the data goes into cloud. And for all our customers, we do have all sort of cloud support, whether it's Azure or AWS or GCP. Yeah, so when we call, okay, RBI is old name, as I mentioned. So we provide for for cloud space, we have consulting, design, infrastructure, application development, migration, then of course support. And at this point of it, primarily focus on AWS and Azure from India, Bosch, I would say. But Google is also another partnership that we are talking about. Some of the instance I've given, maybe they would not know, but we have this connected car, connected battery, connected tires projects are running for different customers, where the data from the cloud, data from battery, data from tire is fed to the cloud, and then you can have a lot of use cases built on it, whether it is servicing, whether it's your downtime prediction, whether your, I would say, maintenance scheduling, all that is possible with this connectivity and cloud on top of it. So we also have partnership, as I said, Microsoft, Google, and the AWS to start with. In the cloud space, of course, we have a lot of other partnerships, including SAP, but in the cloud, we are primarily have this big two, and cloud, sorry, GCP as a third one. So we have Digital Acceleration Center, we have end-to-end full stack IoT solutions teams. We also have analytics team. We have cybersecurity is a very important part. We have a huge team working on cybersecurity, and we are working on platforms. We also build platforms in the automotive domain for the OEMs as well as B2C customers. We work with universities, and I'm part of this presentations, but we have tie-ups with the different universities in South India as well as North India, where we have a lot of events running. We also engage with startups. We have an annual event called DNA, where we work with startups who build similar in the similar tech, whether it's cloud, IoT, IML, blockchain. We work with them, and we are also part of NASCAM and the event. So I've been part of many of these events, part of the presentations in the IoT space, cloud space, AR, VR. We are very active here. One case study I just want to quickly show you. This is a company, but I think you probably know them as Rolls-Royce. But I'm not talking about Rolls-Royce vehicle per se, but I'm talking about Rolls-Royce as a power pack system. So they have this cloud right in the middle of the entire digital transformation journey, and this every single product, or at least in this case, they're the power pack systems that goes into train. For example, that's why we are primarily working. They've got complete connectivity, so they get every second, every minute, or in a scheduled or planned configuration, the data comes to the central system. And this also this is then put under analytics, and this also goes to the customer care center. So when there is a problem that is reported from the field, the immediately the complete data points related to that particular machine, that particular train, what happened in the last few days, and any other anomalies that are seen in the data, or what is likely to be the problem, and then the entire data is given in a mobile app to the service technician. So he's empowered with the data points, have more information, and how to solve it, and what kind of spare parts that he has to carry. and with that he is able to go quickly to the field and he is able to solve the problem, and that helps. The downtime is lesser. You're talking about trains here, so you can't have downtime, and this is of course implemented in the power packs which are going to train across the world, and the whole thing runs on Azure cloud. And this is a solution that we have built end to end over the last, I'd say it's been running for 3-4 years now, and we have a huge team running on UX, running on mobile apps, running on cloud, running on IoT modules, and also have the operations supported analytics teams. Everybody is involved, and this is a big one of the big, I would say, successful case studies that we have. So now we're coming to trends. Yeah. So what are the trends that we are talking about? So this is a typical what you see that as the journey of any technology or any kind of a new thing that goes through. It is primarily adopted by the innovators, which is on the left side. Then you have early adopters and the chasm in the middle. Yeah? Any product is successful when it jumps from the early adopters to the early majority. So here, quite a few of them. I will not go through all of them, but these are the ones which are happening, and how many of them will move from left to right is going to be, we have to wait and watch. But the last one, late majority, as you see, these are already there. Containers, infrastructure as code, monitoring loggings are very advanced. DevOps tool chains are already in place, both in many of these platforms. And yeah, of course, orchestration, Docker, and I think you probably know more about that. And on the left side, there are a lot of new things are coming in, and they would of course take time. They'll move from left to right slowly, and some of them successfully, not all of them, but we will see this. But this is broadly the way the whole the trend you can see in the space of cloud, I would say, and DevOps. One of the key things that happening, what we are also kind of recommending to our customer is serverless computing, and this is slightly somewhere between the platform as a service and software as a service, somewhere in the middle. Yeah, so it means that it's a major change from the cloud computing per se. So the cloud computing, when we see, we predominantly talk about the abstractions over the hardware resources, right? When you're talking about, you can scale hardware, you can scale database, you can scale storage, you can scale computing power, your networking abilities. Yeah, serverless talks about the scaling at the software level. Yeah, it's not about hardware, which means I also abstract the software resources are needed. I mean, my software API is completely abstracted. I don't have to take the pain of defining the hardware requirements for my software. It is completely taken care by the platform itself, which means AWS or Azure. They have their own modules. We call it Lambda functions. We'll come to that. They will take care that my scale, if I have one, let's say my phone connects to a server and 10 phones connect to the server, the entire, let's say Bangalore is connecting to a particular server calling for a particular service. Yeah, everybody wants to know cloud service. I don't have to worry about, okay, adding more servers, more power, more database, more API services infrastructure. I don't have to do that. Yeah, this is completely taken care by the platform providers, and that's what we are showing here. It's hostless. You are not talking about one particular machine hardware. It is completely transparent to you. It's elastic, can scale. There's no state. It's a event triggered. Yeah, that's very important. It means that I would not simply rent a server and then wait for something to happen. Yeah, it will only wake up when I have a need. When the data comes, for example, when my car is sending data to the backend, only on a defined, when it's an emergency, it goes back and hits the backend server. Only then I would have the applications will run, and then it will go back again. So which means that I would not simply rent or provision hardware and wait for potentially the cars to kind of hit my server with the data. It will not happen. So this is a major change, and then which reduces your cost drastically. So especially when you have this high flex, when you have kind of requirements going up, more computing power needed, and then it goes down. In such cases, this is absolutely, I would say, the best way to do it. Of course, it is not necessary when you have very stable, you know that only X number of the hits will happen to the server. You don't have a very wild graph in terms of your requirements, in terms of your hits, then I think it may not be the best one. But when you really don't know, you are not able to predict the demand for the resources, then I think this is the best way. So how does it work? Typically, there's a trigger. So again, as I said, it's based on need, based on event. Only event can trigger the entire chain of activities. Yeah. So only one process at a time, it triggers it. Then you have engine, and then you have all this called functions. At the function level, it is done, and all the functions are again running for your need. And once it's completed, the system goes down. You don't pay for any more hardware for that particular functions. So some of the top serverless platforms that you have is AWS, it's called Lambda, and Azure, it's called Azure Functions. Of course, GCP, we call it as Google Cloud Functions, and IBM Cloud Functions. Yeah, so this is a kind of new trend that's happening. We have implemented something like that in one of our product, connected product, or rather a kind of intelligent product that works on AI, and that would wake up when only when the data is sent, the cloud will basically consume it, and this is done on AWS. The next one that probably must be hearing already is the low code or no code development. So if you're wondering what that means, is basically to empower the non-developers to, when you say no code, it empowers anybody who does not have the software development experience, but also they can build or configure their own reports, configure their own screens without the need of IT team coming in. Yeah. So this is possible with this no code or low code development platforms. So when you say low code, it's primarily very less code is there involved. So it helps the developers basically to design, develop, test, and deploy without writing complicated code, which means it's primarily runs on a visual modeling kind of environment with a UI where you can drag and drop and saying that, okay, this is the box. If this happens, this should happen. This it's basically rules based, for example, in one example. Or you can even configure your own report, because normally when we have requirements, we will say 5 reports. So 5 reports cost you, will take effort of 2 days per report. So 10 days I would need, but this may not be needed going forward. If they are very easily configurable reports, then the reports can be created by the developer quickly, or the end user, yeah, who does not have a software development experience, can also do it by himself. One of very common ones, if you have a Microsoft ecosystem in your college or at home, is Power Platform. For example, there's a tool that I very regularly use is Power BI, which without development, without coding, I could configure and I can create any kind of charts, any kind of reports out of any huge amount of data. Yeah, and I can simply create it. I don't have to be a developer. I can share this with anybody who does not have experience. Somebody sitting in an office, uh, his job is just to create reports. He doesn't have to be an IT guy or software developer. He can just configure and then keep creating reports what is needed by the management or for the organization. And this is something that's picking up. While this may not replace development per se, yeah. So why we have to understand this? Why we have to figure out what's happening here? Because we'll have to see how much of the development, because the entire we are all working in software development, right? And we want to be working in software development, and we want to build software and all that. But how much of this building has to involve manual coding? Yeah, so that's the question. So we are currently doing 95% of the coding manually. We are doing it. There are more and more visual modeling tools are coming in, especially in engineering. But we'll have to see that it is not going to take over complete the role of software developer for sure. But we have to see that whether it will reach 10% or 15%, and that these tools also have to mature. With the more AI modeling and then deep learning coming in, this tool can mature. But at the end of the day, it's all to the benefit of the user, customer, right? End customer. If he wants something to be done, we don't want to develop for 6 months and then deliver. If we are able to use these tools in specific areas, I'm not sure whether I have a slide on that, but if you have, there are very specific screens, web screens, for example. If you want to create a quick e-commerce platforms, it's possible to do it with very relatively low code. There are a lot of frameworks and platforms available, but that would help the customers to, let's say, go live quickly. So we have quite a few use cases where this is possible, but not in all the cases. There are places or requirements or applications which needs manual coding for long. You need time for that. It doesn't happen in short time. The next topic that we are looking at is Bosch AIoT Signal. IoT cycle. So this is the other one. I'm sure that all of you are aware of IoT per se. So we Bosch wants to be called. I mean, we are positioning ourselves as a AIoT company. What does it mean? It's nothing but artificial intelligence plus IoT company. So we already have made huge progress where 99% of connectable products from Bosch are connected. Yeah, which means they can talk to internet. They can be remotely talked to. Yeah. So this is already done. Now we are bringing in next 5 year target is that to bring in artificial intelligence as a common in all this product. 100% all the products either consume, use, or benefit out of AI. Yeah. So this is a what we call as Bosch AI IoT cycle. So what happens is primarily when you develop a product, yeah, for example, you make a washing machine. Bosch makes washing machine, right? So what do? We come up with idea, right? We have an idea, then we have engineering, then we build that how it should look like, kind of different types of washing machines for different kind of use cases, different kind of users. Then it is manufactured, we ship it, and then it reaches your home, right? So then what happens? If you have problem, then you reach Bosch, then they will figure out what's happening. Somebody comes and checks the machine and say, oh, this is a fault, and then they fix it, or they want a change in the product, change in the spare parts, so they replace something and they fix it, right? So what does it mean that unless unless the way the machine is serviced, for example, car, when you take it to the service station, only then the car is reached by the product owner, right? So Bosch does not know what's happening with the washing machine and or dishwasher. So why this is having problems and how we could prevent it from happening, how could we ensure that it lasts longer, right? So this information is not available unless you have very specific connect that happens during a failure or a regular scheduled maintenance. So what AIoT cycle does is it completes the cycle when your product is connected. So when I say when the product is connected, now you have a connected washing machine which talks to your Wi-Fi, and through that it pushes the data to the backend to Bosch, which means that we will be able to understand what how the machine is used, how frequently it is used, and what kind of issues that might happen. And if there's a down, if there's a problem, how quickly we can fix it, how quickly we can the service section can come and replace or fix that. In some cases, even without going to the field, without coming to your home, they can remotely do a software flash, and then it automatically can be fixed, right? So this is all possible, and that's what we call this as a cycle. As you see the value stream, products or services, and the data goes back, and all that happens to cloud. Yeah, and the data goes to the cloud, and then we have a lot of algorithms that are built on top of the data coming in the cloud. And then with that we are able to improve our services, improve the product itself. So the next product that comes will be already have fixed the problem that you would have kind of had in the previous cycle. So earlier it is a 2 to 3 year cycle, but now they are narrowing this the life of the product. So some of the examples here. So this is one of the examples that we have implemented where we are having the sirens, for example, emergency vehicles, ambulance, the sirens. We are building a technology where this information is gathered, and it's continuously this data is fed into the backend. If you can see that, so we have integrated siren detection sensors. They are in the car, and this data is fed into the backend. So this audio data, and we also trying to understand what kind of vehicles, which country has got what kind of siren sounds, and depending on the vehicle from made and all that, we are able to collate this data. And then with that we are able to distinguish between, is it an ambulance, is it a fire service, or it's a police, because all of them have sirens, right? So with that we are able to take certain action. So if there's an ambulance coming in, the car will immediately understand, okay, there's a need for the car to slow down or kind of give way to the ambulance that might be coming from behind, for example. So this is possible to build when you have this AIoT cycle complaint. So this is some pictures how it is done. So we have the sensors in our this is all already part of Bosch that offers in most of the cars, many of the models in Europe. And the second one is that Bosch also has got e-bike. When we say e-bike, any cycle or anything can be converted into e-bike. We provide a hardware. So this e-bike also can be converted into a personal route scout, for example. So this continuously looks at route and arrival time, and it keeps collecting the data about how do you travel, where do you go. So this information is gathered, and it also tries to connect to other drivers as well. And with this information, we are able to understand what kind of road, whether the curves are there. I mean, it's a slope or what kind. If the road is bad, then of course we'll have a lot of vibration. Then it wants that with that data, you are able to provide a better data points for the drivers or the riders, saying that avoid these routes because this is pretty, I would say, bad, and then you should not travel. Or it tells that okay, if you go in this particular route, it takes time because the roads are bad and you will have to ride slower. So this is how the entire cycle is connected. So I've given a couple of examples, but there are so many other similar examples that we have, which has the similar cycle, AIoT cycle, which helps us to provide better services and better products as well. And this is something that we also want to do, or we are doing for our customers. And this is what I mentioned as connected tire, for example, and connected battery, for example. So when we have the connected battery, so we continuously monitor the performance of the battery. When I say battery, it's car battery or your truck battery, and we are able to provide feedback that how long the battery will last, whether it needs recharge, and whether maintenance is needed, they have to refill water, whatever. So all this is possible. We're able to real time get the data, and we can provide services. So when you get a when you have a connected battery, you get an app and which helps you to make sure that you get the maximum out of the product by maintaining it in the right time and able to make sure that there are not many downtimes of your product. The one I would say last, I would say it's the edge computing, and I would like you to look at it on the right side here. So we have on the x-axis real-time requirements, which means that I need data now and immediately. So that is low to high from left to right. On the other side, the y-axis is your volume of data transmission, and from small to high. Yeah. So the cloud computing predominantly happens in the lower left quadrant, where the mails, for example, it has to be real time, but of course it doesn't harm you if it takes extra few seconds. And your internet search, and the volume also is very less. You're talking about 1 mail at a time, 10 mail at a time, but not really high. So this is what the blue color shows us. This is what normally called as cloud computing, where this is the best way to solve it. Then we have something called edge computing. So where do we need edge computing? And this is where we are talking about, let's say, AR, VR, and smart city solutions or smart home. So where the data going to cloud and then having a control back to the field or things, it's going to be very, very, very late. And you need high speed responses. You need immediate action. Let's say that you have a smoke detector, and it has to trigger some actions. This cannot go to cloud, and if he identifies that in next few seconds there could be fire, it immediately acts, it immediately triggers the water, it immediately floods the house, immediately wants the fire service. So the whole thing has to happen pretty fast. And also another thing you can look at, it's also on the higher side of data transmission, because you have to keep getting data every second, how it's happening. And it's also for your games, right? When you're playing a game, you want to take actions immediately, you want to have a lot of things processed in your console rather than going to cloud and coming back. And medical device is also the same. You can't wait. If you have a connected product, connected machine that needs to give you response quickly, you try to keep as much as computing possible in the edge, and not everything happens in cloud, because latency could be too late for this. So the structure, how it normally looks like, you have things, for example, connected glasses, or your AR VR glasses, it's vehicle, or your machines in your factory for pickup, or your traffic lights. These are the things are sensors. And you have edge devices. It could be your phone is an edge device, for example, right? It has got sensors and it pushes the data back continuously. You're tracked, right? GPS is enabled, and Google knows where you're going everywhere. And then you have cloud on top of it, right? So this is a very important developing area, primarily in the context of IoT. But even without IoT, this is still happening, where they want a lot of processing, a lot of computing power closer to the edge of the network rather than in the center in cloud. Yeah. So we have few modules: Azure IoT Edge, Azure Stack Edge, AWS Green Gas are the modules. So what is driving this? Because what is the driver behind this? Yeah. So mobile computing, you need to have location awareness. So you need to know that, okay, if I'm here, if I have an accident, for example, in my car, it immediately informs to the backend saying that, okay, this is the location and this is the situation and this has happened. And you cannot process that in the backend. It is too late. You need immediate reaction. it has to trigger calls to the, let's say, ambulance, also, or fire station. It has to happen then and there. It cannot wait for the signal data to go back to the system, backend system, and then the cloud initiates and somebody manually does that. And fast responsiveness, I think I talked about safety critical on-site analysis and security requirements. You don't want a lot of, let's say, sensitive data, like I mentioned, your research documents, personal data, to be in the cloud. So you want it to be part of your edge within your controllable premise, I would say. Yeah. So what are the benefits? Improved flexibility. So you have to decide where you want to keep your data, whether some of them can be in cloud, some of them can be in the edge. This is possible. And of course, you have a much lower capital expenditure and operational expenditures. You don't have to spend a lot of money for uh, everything happens in cloud, and it's too late when it comes to the edge part of it, and the data is kept on premise, and it's high security. And normally, I would say many of these engineering companies, deep tech companies, would want to keep this in the local premise. Okay, we are exactly on time. 7:15 was the time. So thank you for the opportunity, and I hope I tried to cover as much as possible in this time, to give you an overview on what is cloud, how we have reached here, and what kind of use cases and what's happening. So if you are a developer, if you are somebody who is going to build your career in software, I'm sure that you need to have. Okay, I have to stop presenting. Yeah, so you need to know cloud. You need to understand how cloud works, because as I mentioned, every single application, every single use case is going to be on cloud going forward. Even if you have a private cloud, important for you to understand the cloud part of it, how it works. So hopefully this helps you to get a better understanding of uh, some of the trends and also the concepts of cloud. Somebody has raised a thing. Disha, Chinmay, how do we go ahead? I think we have 15 minutes for question and answers.
Yes, so I'll take ahead. So it was indeed a very informative and deep insight to cloud computing. None in the hundred of us will hesitate anymore if someone happens to ask us about cloud anymore. Thank you so much, sir. You totally killed it like a Bosch, I would say.
Thank you.
Now the meet is open for questions. Please raise your hands in case you have to ask one.
Whoever raised the hand, please, you can unmute and probably ask your question.
So my question is like the companies which store their data in the cloud, if they are going under a cloud migration,
Yeah.
There's a problem of cloud migration, right? Like some of the data, if it is not monitored properly, it might get lost. So to overcome that, what are the protocols do we follow?
So you're talking about on-prem to cloud?
No, sir. From one cloud, like from I'm transferring my data from AWS to Azure, suppose.
Okay. So it depends on the quality of the data and how you have structured it in the earlier migration, right? So when you're already in cloud and you have established I would say a good way of storing it in terms of the data structure, in terms of your overall architecture of how the cloud exists with the data. And you're talking about data, but including data, your schema and all of them, if they are in a good shape, normally it should not make it so complicated to migrate to other one. The complexity only comes when you have I would say two different set of functions, that the way that it is run by AWS and Azure, for example. That's why you will spend time. I would not say that it's so easy that you just migrate, everything happens. I think that's mostly a marketing talk. You would have to spend some time to understand that how do you map this data from your earlier cloud to this cloud. But as long as they have your standard set of data, I would say this framework guidelines and the standards, it is not a big deal. But still, migration normally is not an easy exercise. You have to ensure that every single byte is transferred properly, and that normally happens as a project. It doesn't happen just like that. It's still not reached that level. You need to follow certain, you have to follow, go to the completely migration framework. We have a little bit complex migration framework also in Bosch we follow. You have to do that, and with the due diligence, with the clear, I would say the quality gates, only you can migrate one from one system to another system. system or one platform to another platform.
So one more question, may I?
Yeah, go ahead.
So what about the cloud performance? Like if there is any latency, how do we overcome to it?
I think I gave an example of Netflix. Yeah. So if you click a movie in Netflix randomly, I mean, they don't know which movie you click, but I think it takes less than few seconds to load, right? The first screen to come. Uh, that happens because the investments done by Netflix in keeping these data centers as close to you in highly high performance servers with probably a lot of redundancy, a lot of data, surrounding you. So you have to invest for that, for the latency, whereas there are applications where probably there's no big brands are there. For example, they take a lot of time, the new applications. I mean, even if you compare Hotstar probably um, with Netflix, you can see Netflix is much higher in terms of performance. With my experience, I could be wrong, but there's a difference because that comes with the investments you have done, the kind of uh, what do you say, the expertise with which you have structured your entire database, entire your infrastructure, how you have configured things, how much. Yeah, it's not easy. That's why the experts like you and me would be needed to make sure that with the same amount of resources, how best you can differentiate application from the other, from a competitor. So that is needed. So when it depends. So Netflix invests in making sure that people have a very good experience. So they will invest a lot, but there are a lot of very common applications. Even for example, my Zomato takes sometimes a little longer, but I wouldn't mind. And in some cases, it's not necessary that I need it in for 2 seconds. Sometimes it's okay. In such cases, I think latency is acceptable, but it's all depends on how much you are willing to invest, how best you are able to design and architect such a cloud solution.
Thank you, sir.
Thank you, Atulya. We have Anish with a question. Please go ahead, Anish.
Sir, how to handle the security concerns which arises in the cloud, sir?
Yeah, I mean, this is a very typical. I mentioned Bosch. We are very, very, very skeptical about security. We we still we are in the process of accepting and understanding that it is possible to share our data with Microsoft, or share it's possible to share our data with the AWS or Google. It's not so easy. But as I said, many of the organizations have already migrated. There are very, very stringent, strong legal and statutory requirements are there, and there are very high level of audits also are established, inspections are process are established. So there are levels of certifications are there. The encryption levels are also very high, around 256 bits. So with all that, the cloud companies are, or cloud platforms are continuously kind of establishing that the security is very high and they can be trusted. And of course, there's nothing like 100% secure. We all know that. We are also a security company, but we all know that. But they are trying to show that whatever the necessary, as I said, the framework, certification, legal requirements, and independent audits, independent validations, everything is done, and they keep showing that, keep working on that to give the confidence to the companies to migrate to cloud. Again, you will have to look at that, how critical is your data, how much, so accordingly you can choose. But it's a primary, as I said, that Bosch is not fully there, but many of the companies have started, right from the day one they are in cloud, public cloud, they don't mind. So it depends on kind of data that you have. It's data that is, you can in a whether people will make a lot of effort to kind of crack the data, that is something you have to see. So when it comes to financial banks, for example, and high tech companies who are working on really IPs, they will really think about public cloud. They might keep this data internally. That's why the hybrid cloud is a very good model for them. But if there are very common things that you can have, for example, your website and the data and a lot of documents which are can be, it's not very harmful to put it in public cloud. I think people do that. As I said, that's also a mindset of different regions. But India, I think there's security is not a very big topic. As you know, we don't have GDPR like kind of policies here. We are a little bit like okay, we are open to, we are accepting all the permissions requested by apps, right? But not that may not be the case in, for example, Europe. we simply accept everything. So that's also kind of depends on regions. But yeah, normally I would say uh, the cloud platform teams are doing the maximum they can do. They are satisfying all the requirements to show that they are very secure, even though 100% security is still a dream.
Thank you, sir. Thank you, sir.
Thank you, sir. Thank you,
Thank
Anish.
you, sir.
If
Thank
you
you,
all have
Anish.
further
If you all
questions,
have
you can
further
also drop
questions,
them in
you
the
can
chat
also
box.
drop
We
them
have
in the chat
Chinmay
box.
next.
We
Over
have
to you,
Chinmay
Chinmay.
next. Over to you, Chinmay.
Sir, I wanted to ask if someone is passionate about learning cloud or wants to pursue their career, how would you suggest is the best way to start?
Um, I heard one of
At the start that
the start that they are trying to give you licenses. Many of this Azure or AWS, Google, they offer for any users to start with to understand the cloud. Uh, Especially for students, I'm sure that there will be schemes where they would give you free access to the services. Yeah, so that is one part of it. The other part of it, you have almost for free in Udemy, Coursera. All of them offer a lot of free courses. I do it sometimes when I have time. I try to find some courses which is like completely different from what I'm doing. I'm trying to learn and see if I can get an overview of how things work. So as students, I think it sounds boring. You are only at this point of time, your primary responsibility is to learn, study, and then basically prepare yourself for a potential career in IT in your case. So please spend time in learning things, because the access to you compared to what we were, it's much higher. Everything, like as I said, your cloud subscription, Google will give for free. Azure gives you for 1 year free, for example. I'm not sure about AWS, but I'm sure all of them are giving you free services, access to all the critical services also available, AI services, for example. And you have a lot of learning material available for free. Everything is can be downloadable. Everything is available in videos. So which all of them, you have everything there. I don't, you cannot complain that I don't have enough resources, enough content to prepare, make yourself an expert. You are first year, if I'm not wrong, so you have 3 years, if I'm not wrong. Please spend time understanding, take these courses, avail the services from the platforms. Even if they ask for, let's say, 1,000 rupees per year for some services, I mean, you can invest it. I'm sure that you all would like to buy some mobile phones, you pay for data and all that. Why don't you invest in that also? And if you are able to, because there's no differentiation. I can tell you, my expert who's working for 8 years, for example, in cloud, has the same access that you also have. Yeah, he has the same books, he has got the same Udemy courses, same EDX courses, and he has got the same access. So now with all the services offered by cloud, you can also have a tensor flow services, and you can also have a computer vision services. You can apply it. You can see in a production whether there's a crack in the plastic or not. Your computer vision can study and tell you that. And you don't have to be a master in understanding how it works. It's only you have to understand how the API works, and you're able to call, and you can build applications in no time. So actually, it's very democratic now, where the cloud made everything democratic. You can be sitting, I don't know where are you guys. You can be in a corner of Meghalaya, and you have the same access as somebody sitting in your college lab. There's no difference. Yeah, as long as you got access to all the resources. So my request, I mean, it sounds boring again. Please spend time in reading and understanding and play around. Yeah, build your own game. You try to find some simple use case and try to see that how best you can do that.
Thank you, sir. Now can Kishore take over since you have a question?
Excuse me, sir. How exactly the blockchain domain is related to cloud computing?
So, as I mentioned, blockchain is again going into the distributed computing world. Um, uh, yeah, it sounds very interesting, blockchain per se, but how does it work? Blockchain is nothing but enabling. I think cryptocurrency is a simple example that all of you know. So every transaction is stored across your entire into multiple networks, so that nobody can kind of play around with that. So if I kind of pay you 1 rupee, so it will say that Chandu has given 1 rupee, and let's say Piyush, right? Piyush Amajana. So you, Kishore, you have taken 1 rupee, and this is recorded in all the servers as blocks and unbreakable blocks. Yeah, they are encrypted and stored everywhere. So it is 100%, yeah, 100% ensured that it's very clear that I have given you 1 rupee and you have received it. Yeah, that's how the currency works. So that means that, okay, so with that we are establishing a framework for transactions, and that's what it means. But when you come for non cryptocurrency, For example, IoT, I can give you an example. That's why I can relate to it better. So you go to Ibaco ice cream, or let's say you go to any of the ice creams, I mean, your corner house, right? So what if they offer you the complete life of how the ice cream is made, where the cows were, uh, I mean, they were grazing, and where they, when the milk was taken from the cow, and how it was converted into ice cream, how it was stored, how it was shipped, how it reaches the ice cream parlor. If you are able to provide this entire information, would that make a give you confidence that whatever ice cream I'm having, this is of good quality and will not harm me? I'm just giving an example. Yeah, just give me a second. Sorry, batteries. It's my personal laptop, so the battery is running out of juice. So this is called provenance. Yeah, and I'm just giving a simple ice cream example. But what if I'm shipping very sensitive medical? Let's say I'm shipping Covaxin doses, right? I have to ensure that the transportation has been taken care, that it is maintained in minus 18 degrees, or let's say minus 5 degrees continuously throughout the journey when it came from Delhi to Bangalore, and it is kept also in the lab safely before they are injecting me, right? So this is very critical. How do I know? Helps you. So blockchain, what it does, we can, the continuous data, where when it was sent, the data is sent to the cloud, saying that okay, this is the status of that, and throughout the journey, the vehicle is traveling from, let's say, Mumbai to Bangalore. Every 5 seconds or every minute, the temperature of the vehicle, the container which contains your Covaxin, right, it is captured and stored in blockchain. Yeah, continuously. So that way you are ensured that it is in, I mean, it was always maintained it, and I can safely inject that to, I mean, give the injection to any of the patients, right? Any of the persons who wants to get vaccinated. And this is a very important use case, right? And for this, blockchain can help. So when it's in blockchain, when it's encrypted, it's stored in multiple servers, nobody can deny. So the transport supplier cannot claim that everything was safe when you have the data saying that at some point of time he stopped and switched off the AC. Let's say on the way from Mumbai to save AC, for example, yeah, air conditioner, he wants to save cost. Then you know that it has happened. Either you can penalize him, or you don't have to pay for him, or you can even sue him, saying that he has caused such a kind of problem, kind of a major critical mistake has been done, and you have the data points to show that. Or you can say that out of 10 containers, one of them faulty, so you reject one faulty one, you only pay for the 9 out of 10 only you pay. So this is called smart contract. So in blockchain, we also call it as a smart contract, where you tie it up, saying that if everything, the temperature is continuously maintained from Mumbai to Bangalore, then I pay him 100%. If one batch is not maintained, somewhere it fell and it stopped, the temperature went down, and this is not good for the product, then I pay only for the rest of the shipments, not for the complete shipment. Yeah. So this is a typical example of a blockchain. And this, of course, like I said, it's also built on cloud. I gave an IoT example with sensor and data, but normally IoT is driving the blockchain as well. But of course, cloud is in the middle of it, where the data is captured. Your blockchain applications are built on top of cloud as well.
Thank you, sir.
I hope I answered it.
Thank you, sir. Can I have Piyush with a question now? Piyush, are you there?
So, good evening, sir.
Yeah, Pish.
Yeah, sir, yesterday, not yesterday, but few days back, I was using Google Photos for backupping my photos.
Mhm.
Okay. When I downloaded one of, and since it is using cloud platform, so I am asking you. So when I downloaded the photo, the link from which it got downloaded, I pasted the same link on the another computer on which I was not logged in with my same Google account, but somehow the photo again downloaded. So do you think that this is a security breach or something in the Google Photos?
Ideally, by design or by requirement, it should not happen. So I really don't know what happened there. It sounds interesting. You need to check why it happened. Maybe you have logged in already there in the other PC in the past. So Google has a very interesting habit of remembering everything that you do. So it would have assumed that you already have logged in, so you are still logging in, and maybe with that it gave you access to the particular photo. It's possible, but as I said that at Google it won't happen if there's no access, or if you're not logged into that machine. It's a completely new machine, or if the photo is I'm just making some assumptions, right? If the photo is really stored as a public photo, maybe by requirement it is okay for anybody with a link to share that, right? So this is also might be possible. That's my view, but we have to see exactly what is this case, whether it's really a security issue or it is basically the expected behavior of Google Photos. I'm not a big user of Google Photos, so I really have not had personal experience with that.
Yeah, I got a little bit confused because all the photos were private, and the computer on which I download not mine. It was my friend's laptop, so it was a
And
little
you
bit
have never
surprising.
logged in, huh? Into
No,
that.
I have never logged in with this my Google account on his laptop.
I think you should raise a the no no what could have gone wrong. Ideally, normally Google.
Now, when we're in cloud, we are trusting the company to store it, to store it securely. Like, what backup do you have if the data is lost? Do you have any insurance kind of thing? Anything?
Okay. This is interesting. Insurance. So normally, when you store it, they asked you to accept it, right? The big mails are there, and at the end, you have to say, I agree to the terms and
Yes, sir.
conditions."
Yes, sir.
So I don't know whether insurance is there for that, um, because normally they would not take any liability on top of it, right? Especially if you're using it for free. You store everything in Gmail, right? There's nothing you can do about it. Of course, every Gmail is read by Google, right? They have got bots to read your mail and then understand you better. So they kind of get you acceptance for that. So I don't expect that there's an insurance. Once you've signed it, normally it is not possible. If you're in a commercial agreement that as a company that you have storing there, then of course you are based on your contractual terms. You might probably go for financial penalty or some kind of a compensation for that, but it's only in a commercial contract. But all of you are using your Google, whatever, Dropbox, for example, if you're using Google Drive, when you accepted at one point of time, yeah, I'm allowing you. I think most of the time it may not be easy for you to take any steps on that.
Okay,
But
sir. Thank you.
one thing I can tell you is that very unlikely data gets deleted in cloud. Very unlikely, because normally they would have, as I told you, right, multiple data centers, the data will go everywhere. If you go to US and then open your WhatsApp, also they have to make sure that the images are available for you quickly, right? So they replicate the data. The entire data centers would be continuously synchronizing between multiple regions. So very unlikely once you put it in cloud, it will be lost. It won't be lost. Somewhere they should be able to provide you that. Like internet never forgets, right? What you do in internet is never forgotten. Somewhere it is stored, somebody knows about it.
Yes, sir. Got it, sir. Thank you.
There's one
Thank
more
you,
question.
sir.
Kiran, Nitin Kumar, I think he had raised his
Excellent,
question.
yes, sir.
Yeah.
Sir, how cloud computing is helpful in web development, sir?
Simple. Web development, no longer you develop. I mean, development remains the same, whether it's React.js or AngularJS or ASP.NET or whatever. You develop it, and instead of putting it in a server in your home or in your office, in your organization, you put it you deploy it in the server. That's all. So if you do it in your home, you need a laptop, you need a server, you need all the software for that. But if you put it in cloud and AWS, you just have to just deploy it in the software, and you only pay for the usage. So it's no difference. So the technology for the front end UI and all that remains the same, whether it's cloud or not. Mostly cloud impacts your middleware and backend.
Okay, sir.
Thank you, Nitin. Thank you, sir. Now we will have Chirant KM, and that would be our last question for the day.
Good
Chirant, can
evening.
you please?
Yes, sir. Good evening, sir. Actually, I just want to know how edge computing is related to cloud computing.
I think I gave an example, right? So cloud computing means all your computing happens, your data network, everything happens in cloud, right? You just push the data. But edge computing means that the data, the computing also happens in your local devices. Let's say you have a gateway. I don't know how many of you, hopefully you understand what is gateway. So that's a connectivity machine. So for example, I have this Fitbit, right? You can see my Fitbit. So this is basically a simple machine. It kind of it measures how I do, walk and all that, how many steps. But it does not have connectivity directly. It talks to my phone. So the connectivity happens between my phone and this Fitbit, and from phone the data is pushed back to the Fitbit database, right? That's why when without network I cannot sync. The reason is that the data has to go to server only through my phone. So my phone has connectivity, then the whole thing happens, otherwise it doesn't sync. So in that case, like you said, edge. So when I have got some functions here, basic functions, which means that I can change the screen. Some cases I can probably set the no, I can say start running and then measure how much time. So this calculation, some of the computing happens in this machine. Yeah. So this is the sensor and this is the device, and some happens in my mobile phone, right? And a lot of data is now in the store. So when I ask for 1 month data, how much I worked in a month, this is normally stored in cloud and calculated in cloud. But now if I'm running for 100 meters, how much time I've taken, stops, start stop clock, and all that stopwatch and all the functionality lies here. So the certain amount of computing happens here, certain amount of computing happen in my phone. So this is what you call as edge. Yeah. So in this case, the gateway is nothing but my mobile phone, because that's essentially talks to the cloud, whereas this is the sensor. This senses my my movement, my heartbeat, and all that. So that's the difference. Cloud computing means the computing happens in cloud. Edge means closer to the sensor. So this is the sensor. So this is partially edge device, but main edge device is my mobile phone.
Okay, thank you.
Thank you, everyone. As just a thank you wouldn't do justice to you all for your presence, I would like our co-lead, Kishore, to take over and deliver the vote of thanks.
Thank you, Disha. Gratitude is not only the greatest of virtues, but the parent of all others. Honorable guests, ladies and gentlemen, it gives me an immense pleasure to deliver the vote of thanks for this event to all the dignitaries assembled here. I, on behalf of Cloudzilla NMIT and the entire ISC department, would like to thank the Honorable Chief Guest, Mr. Chandrasekar R. Your presence and wise words helped magnify our cause in the best possible way. All thanks to your enlightening words that inspired so many people out there. I would also take this opportunity to place on record our hearty thanks to Dr. Mohan Kumar SG, Head of Department ISC, for his guidance and his support. I also extend my thanks to Mr. Mohan Kumar TG, Assistant Professor ISC and the convener, and Mr. Kiran BR, Assistant Professor ISC and Faculty Coordinator, and the whole team of Cloudzilla for their cooperation in organizing and managing the event. Finally, I would like to thank all the participants for making this event a successful one. Thank you.
Thank you, Kishore. Everyone, please note that a feedback form will be sent to you shortly. Do fill the forms for certificates. Also, you can reach out to us on our social media platforms. The links will be given to you soon. Thank you. Until next time, stay healthy and stay safe. Thank you, everyone.
Thank you all. Have a nice evening. Bye.
Thank you, sir.
Thank you,
Guys, the
sir.
QR code is just presented here. You guys can just scan and fill the forms.
Thank you, sir, and thank you, everyone.
Guys, before leaving the meet, please do fill the forms.
Can you send feedback link in chat window, this Kishore?
Yes, sir.
Okay. Directly you send feedback link in the chat window. Okay, all the participants will receive the certificate.